Assalamu alaikum everyone. Firstly, it's my pleasure to tell you all about my concerned presentation topic. I warmly welcome you all here. And secondly, let me introduce myself. I'm Sahasagi from the Department of PS Biotechnology, and my assigned presentation topic is primary standards. What are primary standards and how oxidizing and reducing agents are used as primary standards. So let's get started. This is the table of contents that what are the contents which we are going to cover in this presentation. So here they are: primary standards, characteristics of primary standard, reducing agent, and oxidizing agent as primary standard. So first of all, we should know that what is a primary standard. Primary standards are typically used in titration to determine an unknown concentration and in other analytical chemistry techniques. Primary standard in metrology is a standard that is sufficiently accurate such that it is not calibrated by or subordinate to other standards. Primary standards are defined via other quantities like length, mass, and time. Primary standards are used to calibrate other standards referred to as working standards. Okay, so the term titration which is used here basically means the process of chemical analysis in which the quantity of some constituent of a sample is determined by adding to the measured sample an exactly known quantity of another substance with which the desired constituent reacts in a definite known proportion. A primary standard is a measurement that is used in the calibration of working standards. A primary standard is chosen owing to its accuracy and its stability when exposed to other substances. A primary standard is basically used to determine the concentration of unknown substance by comparing it with a substance which have defined concentration and defined proportion. So a primary standard should have basic qualities for being primary standard. So here, have a look. Characteristics of primary standard. A good primary standard meets the following criteria. A good primary standard has a high level of purity, that it can't be impure. A primary standard should be pure so that we can compare with other substance to know the concentration of that substance. A primary standard should have low reactivity so that it can't react with other substances easily. And a primary standard should have a high equivalent weight. So what is an equivalent weight? Equivalent weight is the quantity of a substance that is exactly reacts with or is equal to the combining value of an arbitrarily fixed quantity of another substance in a particular reaction. Equivalent weight is basically have the formula of molecular weight over valency, that equivalent weight is equal to molecular weight of a substance over its valency. Okay, so the next characteristic of primary standard is that it should not absorb moisture from environment. Because if it absorbs moisture from it should change its physical or chemical properties, so it shouldn't absorb moisture from environment, and it should be non-toxic. Okay, reducing agent as primary standard. So here is the example of sodium carbonate. That sodium carbonate is used as a primary standard for reducing agent. So let me tell you all first about reducing agent, that what is a reducing agent. Reducing agent is a substance that oxidizes itself and reduces other. This is a thing that we all know because we have learned about it. So moving on to the formula of sodium carbonate. Na2CO3 is the general formula for sodium carbonate, in which the cation is the sodium and anion is carbonate radical. The common name for sodium carbonate is washing soda and soda ash. These are the common names for sodium carbonate. And why sodium carbonate is used as primary standard for reducing agent. So let me tell you about the reason for using this, that only those acids or bases, reducing agent or oxidizing agent, are used as primary standards which are stable and hence their strength do not change with time. That they should be stable, that their strength shouldn't be changed with time. And the strength of Na2CO3 also do not change, hence it is considered as a primary standard. Anhydrous sodium carbonate can be used as a primary standard. And anhydrous sodium carbonate is sodium carbonate that does not contain water of crystallization. Sodium carbonate is available commercially as an analytical reagent, 99.9% purity, which contains a little water. And the properties of sodium carbonate are some of its properties, like molecular weight, that the molecular weight of sodium carbonate is 105.988 gram per mole. Its density is 2.54 gram per centimeter cube. The boiling point of sodium carbonate is 1600 degrees Celsius and its melting point is 851 degrees Celsius. So moving on to the potassium iodide. Oxidizing agent as primary standard. Potassium iodide is an oxidizing agent and a good primary standard, with one drawback of having a relatively low equivalent weight. So what is an oxidizing agent? Oxidizing agent is a substance that reduces itself and oxidizes other. How reducing agent oxidizes itself and reduces other, in the same way, vice versa, oxidizing agent reduces itself and oxidizes other. And potassium iodide is used as an oxidizing acts as a primary standard because it is stable and has greater strength, and it is used primarily as a stable source of iodine and acid in titration of thiosulfate and sulfite solutions. So properties of potassium iodide are here. Chemical properties. The chemical properties include formula, form, storage, and sensitivity, and its solubility. The formula for potassium iodide is KHIO32. The form in which potassium iodide acts as a primary standard for reducing agent is white powder. Storage and sensitivity, hygroscopic, light sensitive, stored under nitrogen ambient temperatures, that it should be stored under average room temperatures like 20 degrees Celsius or 68 degrees Fahrenheit. This is the normal temperature to store potassium iodide. Its solubility, that it is soluble in water. And its physical properties include its molecular weight, density, boiling point, and melting point. So the molecular weight of potassium iodide is 166.0028 gram per mole. Density 3.12 gram per centimeter cube. The boiling point of potassium iodide is 1330 degrees Celsius and its melting point is 681 degrees Celsius. So that's it. Thank you for listening out my presentation, everyone.